how many grams of carbon dioxide and grams of water are produced? So these are our products. Carbon dioxide, that's going to be gas, and water, we'll say that's a gas. And we're burning acetylene, C2H2. So we're burning a hydrocarbon. So a complete combustion of a hydrocarbon will get you carbon dioxide and water. Okay, so that's a gas. That's what it tells us. It doesn't tell us, but it is a gas. We would tell you all this, the phases, if it's not obvious, we would tell you on the tests. All right, oxygen is diatomic. That's a gas in our air. We need to balance any problem, stoichiometry problem. We need to balance it. We've done this before. All right, carbon, hydrogen, oxygen. Got 2, 2, and 2. Carbon, hydrogen, and oxygen appears in 2 different locations, so we got 2 different lines for them. We got 1, 2, 2 from the carbon dioxide. All right, and then one from the water. All right, we're gonna multiply the hydrogen by 2 because I need this thing here to be an even number, because the left side can only be even numbers. All right, so let me start there. Doesn't matter where you really start; it might just go back and forth a little bit longer. So I'm going to multiply the where I see hydrogen by 2, because that's where the single oxygen is. So I want to multiply that by 2 is what I'm saying. All right, so I got 4 hydrogens there. All right, I got 2 oxygens for that one. All right, so now let's go back and balance the left side. All right, I see hydrogen there, so I'm going to multiply by 2 to get 4. I'm going to update the carbon as well, so we got 4 there. All right, so now let's go back to the right side. Now we can multiply that by 4 to get 4. Update that oxygen, that's right there. It's going to give us 8. We got a total of 10, so now just got to multiply the left side by 5 to get 10, and we should be good here. 2, 5, 4, 2 can't be reduced. Looks good. All right, let's answer these. Now we can do stoichiometry. How many grams of carbon dioxide? So this is the problem here. We're looking for mass of carbon dioxide and all right, we're looking for mass of both products and we're given this. All right, so we got to convert that into both of those. All right, looks like all right, we're gonna need the molar mass. All right, step 1, if you're in stoichiometry. Step 1, if you're not given moles, turn the measurement into moles. 52 grams of acetylene. 52 grams of acetylene. All right, step 1, 52.0 grams of acetylene. All right, let's turn that to moles. How do we do that? Okay, to get rid of a unit we don't want, we put that on the other side of the conversion factor. All right, and put moles on the desired unit on the other side of that. These have to be the same substance here, all right, because it's got to be true. It's got to be equal. All right, let's get the molar mass right off here to the side. Carbon is going to be, there's 2 of them, 24.02. Hydrogen, let's just go with 4 digits, 1.008. times 2 is going to be 1.016. Add them up. 630. Wait a minute. It's 2. Sorry. 26 grams per mole acetylene, molar mass. Right, we need to put that number next to the grams. All right. All right, cancel out those units. Step 2, stoichiometry, convert to moles. All right, so once we have this part here, we're just going to use that for the, we're just going to use that step twice. All right, so we're looking for carbon dioxide, I believe it said. So we're looking to get rid of acetylene, right? So mole, this is called the mole ratio. This is where you convert from the given substance to the desired substance. All right, so One of the desired substances is carbon dioxide. All right, let's go check out our mole ratio using our balanced equation. All right, it is a 2:4 ratio for that. 2:4 ratio. What was it? 2 2:4. 2:4. Boom. All right, final step in stoichiometry is to convert to the desired unit. I believe it asks for mass. What's the gram? How many grams? How many grams of carbon dioxide? So, another molar mass. Okay. All right, moles, carbon dioxide, to grams of carbon dioxide. Wish we could just round because then it would be like 32 plus 12. Carbon 12.01. There's one of them, and oxygen is 16.00. There's two of them, and there's 32.00. Add them up. 44.01 grams per mole. Let's cancel these out. All right, punch those numbers in, and we'll get our answer for the carbon dioxide component. 52 divided by 26.036 times 4 divided by 2 times 44.01. We're not going to round yet. We'll just take it to 4 digits. We have 175.8 grams. This is not our final answer of CO2. All right, well, we'll just save that. We just got to add that to our because also asking what's the mass of that and water. All right, so here's what I'll do. I'll just copy this. I don't want to do this again. Copy that. All right, now I'll just do the same thing with water. All right, get rid of moles of acetylene. Oh dear. And we want moles of water. Again, this is called the mole ratio. This is where we get rid of the substance we don't want and get the substance that we do want. All right, let's check out our mole ratio between acetylene and water. All right, acetylene and water. All right, it's a 2:2 ratio or 1:1 ratio, so it's not gonna. Don't need this step, but we'll do it just to show our work. All right, and the final step here is to convert that to grams. Right, that's molar mass. Get rid of moles and end up with grams. All right, that's molar mass. All right, it's 1.008 times 2.016, and then oxygen 16.00. Let's add them up. 18.016 grams per mole is the molar mass for water. So molar mass, we're going to use that as the conversion factor right there. Anytime we're going between mass and moles, we use the molar mass. All right, let's punch those numbers in now. 52.0 divided by 26.036. I'm not going to do that. They're just going to cancel out. Times 18.016. All right, so now the H2O mass is 35.98 grams. So we need to add these up. This number and the number we just got right there in black. All right, so add that to 175 right here, 0.8, and that's going to give us our total mass. Now we can round. This is our final answer. Final answer. 212 grams of carbon dioxide and water. It's the mass. All right, is there another? I think there's another part to this. There is. All right, how many moles of water? Why did they switch it up? Could have used the same number. All right, we have the equation, so it's not too bad, and we have the molar mass. So step 1, stoichiometry. Let's convert that to moles. 64 grams of acetylene to moles. 64.0 grams of acetylene, convert that to moles. Right? So we want to get rid of grams, so put that on the other side, and we want to end up with moles. Put that on the other side of that. Okay, and these, in order for molar mass to be true, you've just got to be concerning the same substance. All right, now we figured this part out earlier, so let's just copy that. It's right there, 26.036. All right, we got rid of that. Now let's turn this into the desired substance using mole ratios. Moles of acetylene, we want to get rid of that. And what is it asking us for? How many moles of water? Oh, we're done after this, because moles is the unit we're going to be left with. All right, so what's the mole ratio? 2 to 2. Don't even need this step. So it's just 64 divided by 26. Let's 64 divided by 26.036, and the answer is going to be 2. How many sig figs we got? 3. 2.46 moles of water.